Okay, guys, so we will start with the team number one. Okay, so for team number one, they have a flash system, a flash and distillation column. So they have CO2 in the feed, followed by methane and also propane. Okay, since we know that, saya conteng dulu. Oh, pakai laser lah. Okay, since you have a CO2 here, then it is easily for you to remove it through flash, and you cannot and you cannot use distillation column since CO2 is non-condensable gas. Okay, all right. So the first control loop is pressure controller here. Okay, so for your information, controlling pressure in a feed stream is impossible. Okay, so this is not a feasible control loop because pressure only accumulated inside a vessel, inside an equipment with the resident time. Maksudnya dia equipment with the resident time meaning there has a certain volume, there has a certain time required for the component to stay within, okay, to stay within the equipment. Sebab tu kita panggil dia resident time. Whereas kalau dalam pipe, there is no resident time here because you don't hold it. Okay, so you cannot have a pressure controller at the feed. So usually at the pressure controller, one thing yang kita boleh pakai adalah at the feed stream adalah adalah flow rate. So you control the flow rate. Okay, you control the flow rate in the vessel in order for you to maintain. So the objective here is to maintain the capacity of production. Okay, capacity of your production, but not the pressure. Okay, all right. So that should be the first one. So yang lain pun kalau ada, usually we flow control the feed. Usually we flow control the feed. So what happened inside the flash? So there is a two phase here. So this is a liquid, and over here is a vapor. Okay, liquid and also vapor. So as I mentioned yesterday, so what will happen if you have an accumulation of liquid inside the vessel? So apa yang kita perlu control? So it's not a flow here.
Level.
So basically here is a level indicator controller. You need to control level since you have accumulation of liquid inside the flash. Okay, so this should be a liquid. All right, so since this is flash, you have a two phase. You have a liquid at the bottom and you have a vapor at the top, and this is accumulated. This is a closed vessel, so it is accumulated. So remember that the pressure here inside the vessel are the same also with the pressure here. So this is not a flow, this is basically a pressure control system. Okay? Then you can either measure the pressure at the inside the stream, or you can measure it directly from the vessel. Okay, so that's all for the flash. Since you have a 3 number of control valves, meaning you only have 3 control loops. Okay, so usually when you want to design a control system, just look at the number of control valve available. So meaning that is the minimum, or not minimum, the maximum number of control loops that you can design. All right, flash. This is the flash. So you want to recover CO2 here? Yes, that's right, because you cannot condense CO2. All right, now we have a distillation column to separate ethane and you got propane. Okay. Again, the most important when we are talking about distillation column, first thing first, you need to look at the hold up. There is a liquid hold up down here. Bukan atas ni ya, atas ni ini the stage. So there is a liquid hold up down here. So you need to have a level controller here. That's right. But you don't measure it until here. You should measure it down here. Okay. Because it's a bottom level, not the stage level. All right. And since you have distillation column, you need to have something at the bottom to maintain the product quality. So therefore, you need to have here is a temperature control. Yes, this is right, but you measure the stage, not you measure a vapor boil upstream. This is a vapor boil upstream. You need to measure any stage temperature. Okay, it should be come from stage temperature, and then you manipulate the cooling, the fuel ataupun the steam to the reboiler. All right. So this is right. At the top, so you have a three number of control valve. Therefore, you need to have a 3 control loops here. So first level, okay, this is right. And then pressure by manipulating the cooling water. Okay, right. And to maintain, remember that you did something to maintain the composition. Therefore, you need to have a flow control of the reflux flow rate. Okay, so this flow control of the reflux flow rate will maintain the reflux ratio. So you have a distillate here, and this is the R reflux. So R over D is the reflux ratio. So you need to maintain by manipulating the flow rate over here, the reflux flow rate. So kalau D dia, okay, 1, so if the ratio is 1.2, therefore this is must be 0.2 extra, 20% extra coming back to the column. Okay, team number 1, you need to do this correction if you want to proceed for your variable classification.
Okay.
Any other question? Ada soalan? Team number 1?
Buat dah correction tapi tak post lagi.
Oh, yelah tu. Okay, so we continue with the team number 2. Alright, this is team number 2. Alright, okay. This is reboil absorber. Okay, to maintain the product composition, alright, product capacity, right? This is right. Okay, temperature, right, level, of course, but this is not over here. You need to measure down here, the bottom. Pressure, okay, good. Temperature, level, again, level indicator should be down here. Level here. What is this? Pressure, okay. What is this? Kenapa tak masuk dalam control valve? Oh, sorry. This one should go to inside the control valve. Alright, team number 2. Only the location of your sensor. The rest is excellent. Thank you. And all our feedback. Team number 2, okay?
Okay.
Okay, doctor.
Alright. Thank you. Team number 3. Wow. Kita take on one by one.
Oh, pening.
Siapa yang buat ni? Sampai pening. Okay, you have two distillation column in series here. Since you want to produce propane, you recover propane at the top. You recover pentane at the bottom of your distillation column, and then after that you recover propane and butane at the second column. Okay, this we call it indirect sequence. Okay, indirect sequence means you recover heavier first at the first column, which is pentane. All right, so the first loop is right. You want to flow control the feed such that you maintain the composition and the capacity, the production capacity, pressure control here, all right, by manipulating the cooling water flow rate. Okay, this is right. Level, okay, but not here, should be down here, level. What is this? This your flow control the steam. Okay, so this is not right since your objective is to maintain the temperature, to control the temperature for the product purity. So you need to have a temperature control here. Level, okay, this is level of reflux drum, right? Okay. You may have this kind of a ratio control, okay, but why that you need to have ratio control rather than just flow control the reflux? Okay, so this is not wrong, but you need to specify. Okay, usually I will ask you, why not just feedback control your reflux flow rate? But whether this is right, tak salah pun. Okay, all right. Okay, that's for the first, and the second will be almost the same. You're not measuring at the top here, you're measuring down here. Okay, don't flow control the steam flow rate. You need to measure directly, you control directly the temperature at the bottom of your distillation column. This is okay, this is right, and again, this is, usually we'll use the ratio, okay, if the, what do you call it, there is a requirement for you to measure the distillate here. Okay. Usually, if your, what do you call it, distillation column is stable, it's not affected by the disturbance, then the ratio will be the right configuration. Why? Because your propane here, your distillate will fluctuate. Okay, your distillate will fluctuate. But since you already feed, you already flow control your feed flow rate over here, therefore the mass balance over here throughout from the first column to the second column will be maintained. So therefore there won't be any fluctuation in the distillate flow rate. Therefore, no need to have a ratio. Okay, the ratio controller here. But it's nothing wrong. Okay, in this case, nothing wrong that to use the ratio controller here. Okay, all right. Team number 3.
Okay.
Okay, do the correction.
Baik, Doktor.
Thank you. So you know why the reason that you need to have a ratio control. Bukan saja meletak-letak je. Okay, team number 4. The team number 4 here, you have a condensed absorber at the first and you have a distillation column at the second. Why that you need to have a condensed absorber? Any reason here? Because you have ethane at the top. Okay? The range between ethane and the pentane is quite far, quite big. Therefore, you need to have a condensed absorber. And as you know, the pentane and the hexane and at the atmospheric condition will already become a liquid. So no need for you to reboil it. So ethane should be recovered at the top as a vapor, then you condense it. Yeah. Feed flow rate control, yes. This is wrong. It's not the temperature. It should be a level control here. Because you need to maintain, okay, since there is accumulation of the liquid here. Okay, If you want to temperature control here, you want to control temperature, what should be your manipulated variable? You need to something that relate to the heating utility or cooling utility. You cannot control temperature by adjust by manipulating the bottom flow rate, because bottom flow rate does not carry any heat duty. Okay, so never use this kind of control design for your reboil condensed absorber. Okay, that is at the bottom. Since you only have a one control valve, therefore only one controller that you can design, which is quite important, which is level control. All right, so we go to the top of the condensed absorber. So we have a pressure control here. All right, so this is wrong. You cannot use PC since you don't have a transmitter. If you have a pressure indicator or pressure transmitter, then you can have a PC. Otherwise, we just use PIC. This one require for you to have a measurement. So you need to have a PI over here. All right. So do the correction. Okay, level. If you don't have a measurement, then you just use PLIC. This is right. And this is right, but you don't need to have a flow indicator to measure. Okay. So the flow control of the reflux flow rate is used to maintain the composition at the top, the purity at the top. Okay, that's the condensed absorber control system. Now we go for the second column, which is distillation column. All right, so we go to the bottom. Usually at the bottom, we need to maintain the level over here by measuring the bottom level and level control it by manipulating the bottom. Okay, this is to maintain. Yes, saya.
Ada orang nak masuk.
Oh, do I need to kena mana? Tak ada mana? Rasanya boleh masuk je. Mana dia?
Kejap.
Payam ah? Bukan dia dah masuk ah?
Yusof.
Dah masuk ah? Sebab tadi ada banyak yang masuk. Okey. Boleh kan masuk kan? Kayum aja. Oh, Yusof yang ni. Okey. So yang lain tu dah masuk ah? Ada 60 ni, ada lagi 4 orang. Okey, so kita sambung ah. Kalau ada yang hang sebab saya tak pergi, sebab saya pergi kat Jambox sekarang sebab tu yang lain tu dia start. Okay. So we continue at the bottom. So usually if you have a column, make sure that you level control the bottom of that column. Okay, here. Okay, this is right, but you need to have a temperature indicator before the temperature control. Okay, so this make the correction here. The temperature control over here will determine the quality, will determine the purity ataupun composition of your bottom product. Okay, that's the bottom side of the distillation column. Now we go to the top side. This is level control, right? Pressure need to be controlled by manipulating the cooling water flow rate, but here need to have an indicator. And last but not least, you need to have a flow control here for your reflux flow rate, because this will determine the quality. Okay, team number 4, do the correction.
Okay, Doctor.
All right, thank you. Team number 4. Oh, next team number 5. Alamak, tak nampak sangat.
Nak dengar Fadlul present.
Team number 5.
Hello. Salah, boleh dengar
Okay, team number 5, you have a condensed absorber plus.
Kita mula dengan Adil dulu lah. You share your slide.
plus this distillation column. So here we recover ethane and propane at the top. We cut over here. And these two need to be in the liquid. Since we know the pentane, propane and pentane, there is a big range there. So therefore, these two should be, the condition in the feed here, this should be at the, as a liquid. These two should be at the vapor. Therefore, you can recover it and you condense some of the pentane and pentane recover at the bottom here. Right. So the first is flow control, okay, of your feed. This is right. And again, for the bottom, always control the level, not the flow rate. Okay, always control the level you measure here. Okay, you measure here. So there should be a level indicator controller. That is compulsory. For me, level and pressure is compulsory.
Mana punya raw, awak lukis tak raw TGA data?
Tak nampak? Ini FIC ke PIC ke apa ni?
Saya bagi
Itu
data
PIC,
TGA
Pressure
Okay.
Indicator Control.
Alright, kalau PIC betul.
Awak draw tak apa?
Alright, so this is wrong. This is you need to use to maintain the level at the reflux drum. Okay, that also will determine
Awak clear dengar tak?
the top composition, not the top stability.
Awak dengar tak?
Okay, the top mass balance. Okay, and you need to have a flow control of your reflux flow rate here to maintain the product purity. Okay, maintaining accumulation. Okay, kita dah tengok semalam that accumulation can be in the three form. Okay, a liquid, accumulation of liquid, control level, accumulation of vapor, control pressure, and accumulation of solid, you control the mass or the weight. Okay, mass. Okay, so this is for the condensed absorber. Next is the distillation column. Alright. Kita ada dua kat bawah ni. So first thing yang penting adalah level here. Okay, level controller. And this should be temperature. Ni temperature ke ni? T berapa tu? TIC ke tu? Saya tak nampak.
Temperature.
Yelah, apa dia punya? TC ke TIC?
TIC.
TIC.
TIC betul. Nah, ini betul. Ini sama macam tadi. Tolong betulkan. This is a level. And this is a flow rate control of the reflux flow rate. Okay. 5. Clear?
Clear, Doktor.
Okay, do the correction. And we go to the team number 6.
Doktor, jap.
Oh ya, kat mana?
Untuk FIC yang dekat bahagian reflux, maksudnya
Aha.
dia kena connect dengan condenser ataupun connect dengan column?
Ni kan flow sahaja ni.
Aha.
You
So,
flow
dia
control.
dengan-
Stream ni you flow control. You control the flow rate. Stream ni. Stream ni dengan stream ni adalah flow controller. Flow rate controller. Okay. That is the basic. That is the basic. Kalau nak advance, then you can use a ratio control. Macam ni. Team nombor 3. Where you need to measure both reflux flow rate dan juga distillate flow rate to maintain the reflux ratio, which is R over D. Okay. Mana tadi? Okay, ni. So, okay?
Okay.
5? Yang lain kalau ada soalan pun boleh tanya. Kau yang nampak serius ke? Mikir, pening kepala mikir. Ya Noha, ada soalan Noha? Kau on mic tu.
Jap, saya terfikir satu benda lagi.
Apa dia?
Kalau macam dekat feed stream,
Mhm.
either one yang dalam ni, Dia macam okey ke kalau kita pakai temperature controller?
Kenapa
Betul
nak
tak?
control temperature pada feed?
Sebab entahlah, sebab saya rasa macam dia kan material yang lain. So dia punya boiling point pun berbeza. So dalam distillation column tu mesti dia ada set point dia punya temperature kan? Ke dia tak kira macam tu?
Okey, maksudnya pada feed tu awak control temperature.
Mhm.
So what do you manipulate?
Akan
Kita
flow
tengok,
rate.
kita tengok dalam, okey, tengok yang case yang ini, tim 5 ni. Okay. How does you increase? Okay, tengok ni, kejap saya pergi ke laser. How did you increase the temperature here? Ini feed kan? How you increase the temperature? On how you reduce the temperature here?
Dengan cara adjustable flow rate.
Okay, kalau adjust flow rate, temperature boleh naik, boleh turun ke?
Bukan ke kalau macam flow rate dia sikit, macam apa, yang feed dia masuk sikit, so temperature dia akan lebih cepat untuk berubah.
Temperature kat mana? Kat stream ke kat dalam kolom?
Dekat dalam kolom.
That's you're talking about down here. You're talking about this. This you already have a temperature controller for the bottom column here. There's nothing to do with the feed temperature. Feed temperature, kalau you nak control, you need to have at least you need to have a utility sini. You need to have a cooler kalau you nak reducekan temperature. Or you need to have a heater kalau you nak increase temperature. So you kena ada satu lagi utility here. Heater ataupun cooler. Baru you boleh control temperature of the feed. Kalau you just open and close flow rate, yang berubah adalah flow rate. Okay?
Okay.
Sama juga dengan pressure. Pressure kalau you nak increase pressure of this stream, feed stream, need to have a pump. Sebelum masuk ni you kena pump. Supaya pressure of the liquid increase. Ataupun you kena ada compressor supaya pressure of that gases dalam ni, dalam stream ni increase. You tak boleh just by open or close, by opening or closing the valve, temperature or pressure will increase. No, tak boleh. That's why you require a utility or you require auxiliaries. Kenapa yang sini, kenapa yang bawah ni, kita boleh control temperature dia?
Sebab kita nak jaga purity yang keluar tu memang betul-betul
Yeah,
purity.
that is objective. Okay, that is objective. But why that? How that this able to maintain temperature, able to control the temperature? What do you have down there? Ni apa ni?
Reboiler.
Reboiler buat apa? Increase or decrease temperature? This reboiler will increase the temperature because it's supply. This is steam supply here. Sebab tu you can able to maintain temperature down there by manipulating the steam flow rate to the reboiler. Temperature drop. Okay, let's say you close valve sini ya. You close valve sini, then flow rate jadi rendah. Okay, temperature increase kat sini, you cannot maintain up whatever sebab you tak ada controller kat sini. And once dia temperature naik, composition akan jadi vapor, so dia naik atas. Naik atas, keluar atas ni as vapor, masuk dalam condenser, so the heavier akan jadi liquid. Then you patah balik. Okay, your product will be recovered here. Okay, masuk. Since yang ini you dah reduce, therefore yang masuk sini akan rendah than the previous. Then when come over here, temperature will increase. Tapi kat sini, since temperature increase, you may close the steam here, such that temperature will suddenly maintain. Sebab you ada utility sini. Sebab tu Distillation column tak ada masalah nak maintain temperature because you have a utility at the bottom. Ada lagi tak?
Tak ada, tu je.
Yang lain ada apa nak tanya? Rizwan, angguk terkukur je kau. Giling-giling pula.
Saya.
Giling-giling kecapi. Ayom, dah gatal kepala.
Okey doktor, okey.
Okey je doktor.
Okey pula kau punya mic hari ni ya. Ada siapa lagi start? Tak boleh masuk? Apa yang O-nya Fika? Manjang ni kau O. Okey, kalau tak ada soalan kita pergi kepada team number 6. Team number 6 adalah double distillation, two distillation in series. Okay, configuration yang ini kita panggil dia direct sequence. Kenapa dia direct sequence? Sebab kita recover light component at the first column. Kita recover propane. We recover propane, that's why we call it direct. Direct sequence mean you recover most volatile component first at the first column. So ini kita panggil direct sequence. Okay, direct sequence. Yang case tadi mana? Okey, bukan ni. Mana dia? Tim nombor 2 ke? Okey. Untuk tim number 3, this is we call it indirect. Okay, this is indirect sequence. Kenapa? Sebab we recover heaviest. We recover heavier at the first column. Kita potong di sini. Kita potong, kita ambil, kita buang pentane dulu. So dia paling berat. And the most volatile will go at the top. Ini kita panggil indirect sequence. Whereas team number 6 adalah direct sequence. Sebab we recover light component or most volatile component at the first column. Itu beza antara direct sequence dengan indirect sequence. Okay? Alright, now let's look at the design process control of this team number 6. Alright, you flow control the feed flow rate, okay? Nice. Then we look at the bottom. Okay, okay, temperature here, okay, this is right. Alright. This is my question. Any members of team number 6, why that you need to flow control your distillate, your bottom flow here? Anyone? Any reason why? Any idea why that you need to flow control that bottom flow rate before coming in to the second column? There must be some reason, right? Sedangkan feed yang masuk pada first column, you dah flow control. Yang nak masuk second column pun you flow control juga. Because of two component. Kalau two component, kenapa you nak flow control? Remember, you are talking about flow rate. We are talking about flow rate. So the overall flow rate of this plant, of these two distillation column, already maintained by the first flow controller at the feed. Okay. So what happen kalau yang first tu kita nak besar dia punya flow rate, tapi yang bawah ni tiba-tiba dia jadi slow. Dia bagi you nak dia lagi kecil. Then there is a contradict. Okay, there is a contradict. Since you need to know that mass balance. So what's coming in, that's go out. You need to be balanced. Okay. And since this is continuous, therefore controlling the flow at the second column basically will make the system not smooth. Okay, if this is your design, then the overall operation here will not be smooth because ini akan menyebabkan you punya flow rate stuck di sini. Okay, since you have any specific flow rate over here. Okay, so kalau masuk sini banyak, yang ini kita tunggu dulu. You need to wait until this do the action. Then again, there will be more accumulation at the bottom at this bottom column. Then sometime this bottom will be flooded. Okay, therefore it is advisable for you to just level control here the bottom rather than you level control flow control of the bottom flow rate here.
Doktor, boleh repeat tak? Sekat lah.
Repeat kat mana?
Yang kenapa tak boleh letak flow control kat situ?
Kenapa sangkut ke? Okay, petang-petang ni banyak sikit apa orang guna internet kadang-kadang slow. Okay, sekarang clear tak?
Doktor,
Ya.
maksudnya yang doktor cakap tadi flow rate dekat kawasan tu,
Mhm.
kita kira akan ikut dekat accumulation yang first column kan untuk control that flow rate.
Okay.
Macam tu.
You kena tengok overall total mass balance. Okay, you look at the overall total mass balance. Okay, I draw a boundary over here. Oh. Okay, I draw a boundary over here. Oh, sorry. Okay, yang masuk ada satu kan? Betul. This is your this is a boundary, so this is our feed in. And this is your feed out. 1, 2, 3. Then you have a 1 input stream and 3 output stream. So this is a CMOS process. Okay. You need to remember that since this feed stream is already maintained, okay, it's already maintained. Therefore, whatever comes in over here is equal to this plus this plus this. Clear that? So this one finger stream over here is equal to this plus this and plus this. All right. If you already maintain over here the flow rate 100 for example, adakah yang dalam ni penting? Yang penting kita kena tengok kat sini. Adakah sini 20, sini 20, sini 40 contoh, ataupun sini sini 30, 30, sini 60. Ataupun 40. So it's still 100. Itu yang paling pentingnya. Whatever here, kita tak perlu ambil tahu pun. Sebab we need to balance the mass. Mass in satu stream ni should be equal to mass out from these 3 streams out. Stream out. That's why in the middle doesn't matter for you to flow control it or not. Sebab ni yang paling penting tau. Okay. Feed stream ni paling penting. There's a lot of things that you can do here. Kalau berubah saja, the whole thing ni will disturb. So once you flow control the feed stream, any flow in between tak ada, kita tak taking into consideration. Kalau when you're talking about flow rate, dia berbeza dengan yang ni yang atas ni. This is not talking about flow rate. We are talking we're talking about purity. Okay, you control the flow rate of the reflux is basically for you to maintain the quality of the top composition by maintaining the ratio of the reflux versus distillate flow rate. Afika, okay?
Okay, Doktor.
Okay, sebab tu once you already flow control your feed stream, you tak perlu ada lagi feed flow rate control in between. Okay, otherwise dia akan ada dua, tahu tak? Dia akan ada dua benda yang berlainan. You dah masuk dalam stream number 1, dalam kolom number 1, dan bila nak masuk kolom number 2, tiba-tiba stuck pula situ. Okay, ada pula roadblock situ. Jadi tak smooth lah you punya operation. Remember that control valve tu adalah macam roadblock. Polis yang buat roadblock. Dia benarkan kau masuk, dia buka. Dia tak nak kau masuk, tak nak lepas, dia tutup. So the process will be not smooth. Kalau time you nak masuk dalam second column tu, dia tutup. Dia cakap, okay, depan tu dah ramai, dah penuh. So you kena tunggu. So once dia close, then what happen? The previous tu akan stop juga. Then you kena tunggu, lalas accumulated. So kadang-kadang berlaku flooded dalam you punya first column. But you ada flow control untuk second column. Okay, you ada flow control to the feed of your second column. Okay, that's about why that you cannot have the flow control in the middle, the flow control in the middle, because this already, unless kalau yang ini tak ada. Okay, you don't flow control ini, then you may have here, you may, because this will determine your product juga, your capacity. Alright, so it's not recommended for you to have a flow control here at the bottom. Okay. Alright, so the bottom of the first column, okay, clear, right? Next, we go to the top of the column. So you have a, mana control valve dia hilang. Okay, pressure control there at the top. Hey, pakai ini pula. Okay, this is right, pressure control. Reflux drum level control, right? And this is reflux flow rate control, okay? So the first column is clear. Now we go to the butane pentane column. Alright, yang ini betul pula, you control level. Okay, you should measure is here. Measure at the bottom of the column, bottom stage. Okay, you maintain the level here to maintain your mass balance. Okay, you use the temperature at the bottom to maintain the bottom product purity, right? Okay, you manipulate the cooling water flow rate to the condenser to maintain the pressure at the top. That's right. Okay, to maintain the top mass balance by controlling the level of the reflux drum and maintaining the reflux ratio by controlling the reflux flow rate. Okay. All right, team number 6, do your correction on this. Ada apa nak tanya? Pika? Yang lain ke, Noha?
Ya, Doktor.
Okay, Noha. Ada apa nak tanya? Pika, ada apa nak tanya? Tak ada? Qayyum tak payahlah. Dia dah tunduk kepala tu.
Kesian tu Dr.
Izzuan,
Qayyum.
kau apa? Kau berzikir ke, Izzuan? Alhamdulillah. Ngaku je lah, Alhamdulillah lah, zikir.
Alhamdulillah.
Noha tengok pun, oh baiknya Izzuan ni geleng-geleng kepala, berzikir. Okay, so kita pergi kepada last team, group number 7 only. Okay, this is a little bit different since you have two. Ini kalau you silap operate, jadi tunggang langgang you punya sistem, you punya proses. Okay, you have a SO2 here, and also you have a water, and you have a ethane. So this is very, we can say this is more on the gases separation. Okay, gas separation. Okay, guys, if sulfur dioxide react with water, what do you have? What you gonna have? Apa akan berlaku if sulfur dioxide akan berbalas dengan water?
Sulfuric acid.
You will have, what kind of acid do you have?
Sulfuric
Acid do you
acid.
have? Sulfuric acid. So sulfuric acid ni apa?
Sulfuric acid.
Ha? Nak tiga apa dia tu?
Yang tidak balas dengan air.
Ya tak tahulah sulfuric acid. Nak tiga apa dia? Munggo.
Acid.
Iyalah, acid apa? It smell like acid.
Asid
Dia
yang kuat.
jenis acid yang mengakis. Strong acid tak juga, you need to look as the, of course it's a strong acid, tapi tengok pula dia punya number of mole, dia punya kekuatan dia. Tapi ini adalah jenis yang mengakis. Mengakis ke mengkakis?
Menghakis.
Hakis. I don't know. Okay. Bahasa Melayu saya ni lemas. Korosif. Yes. Yeah, that's the better word. Thank you, Irene. Korang nak guna bahasa Melayu pun tak erti. Senang guna corrosive saja. Okay, it's a one of the corrosive acid. Okay. So if we remain it, if we put these two together, contact with each other, then what do you think will happen to your plant? Fikir.
Rosak. Equipment rosak.
Equipment apa yang rosak?
Piping semua acid.
Yelah, apa yang berlaku? Dia takkan rosak macam tu je.
Dia punya integrity piping tu rosak dan terganggu.
Yeah, we are talking about integrity. What type of integrity that you look at? Kat mana korang belajar integrity? Ada belajar integrity ke?
Tak ada.
Lepas tu tiba Aziz keluar word integrity. Oh, dia banyak baca. Okay. Assume dia banyak baca. Bukan macam Qayyum. Itu
Berkait dengan PSN saya, Doktor.
Hai, kesian kau yang kena je. Asyik kau je kena. Tukar orang lah pula. Muhammad Aziz lah pula. Izwan tadi dah giling-giling, dia dah stop giling dia. Tak giling. Okay. When you have this, we call it acid gas. Okay, sulfuric acid pula, SO2, H2S, H2SO4, that is basically we call it acid gas. So you need to remove as fast as possible. Okay, buang dia terus, jangan simpan dia lama-lama. Okay, so sekarang ni what happen, dalam feed dia tak berlaku, dia tak react. Kenapa dia tak react? You have a SO2 over there and you have a water. Water. So you have a water over there. Then you have a ethane. So kenapa tak ada tindak balas berlaku dalam tu? Any reason why you don't have any reaction happen there?
Sebab tak ada high temperature.
Ada high temperature? Good try, but not the right answer. Yang lain?
Combine with water.
Ulang balik Izzah.
Sebab dia bind with water.
Bind with water. How does it bind with water there at the feet? What condition that it required to bind, to combine, to react? Tak terjawab tu Izzah. Lagi. Come on. Why that there is no any reaction there in the feed stream? Sedangkan you ada SO2 di situ, you ada water di situ.
Sebab itu dia apa? Dia ada reaction dengan water tu.
Ethane.
Dia soluble.
Apa masalahnya ethane pula? Kenapa ethane
So,
boleh
dia
jadi pengacau tu? Dia macam ginilah Noha, macam kau dengan Qayyum nak berdating tiba-tiba, okey, ada si Kanzul situ. Kanzul tu ethane lah tu pengacau. Itu. Contohlah.
Ada ni Kanzul ni.
Tiba-tiba kan, tiba-tiba contoh tak ada, that is not the answer. Tak payah melibatkan ethane, tak payah melibatkan si Kanzul dalam hal ini. Qayyum? Kalau nak cakap, terus. Apa lagi cepat? Kenapa tak ada reaction there? Korang dah belajar chemical reaction kan? Apa requirement? So, apa benda yang paling basic that you require such that reaction happen?
Suhu.
Suhu? Okay. Lagi?
Mungkin sebab dia immiscible reaction.
Immiscible reaction? Tak juga.
Presence of heat.
Presence of heat. Where you don't have any heat there. Tak ada pun heater situ. Generical catalyst. Kat mana catalystnya? Oh, catalyst tu ethane jadi catalyst. Kalau contoh kalau si Kanzul jadi catalyst, laju je si Qayyum dengan tu nanti. Oops. No. There is no presence of catalyst unless if the ethane become a catalyst. Temperature, yes, you require the temperature, tapi how do you have a temperature? How you increase or decrease the temperature at the feed? Okay. One thing yang you need to remember, okay, please refer back your chemical reaction textbook. In order the reaction to happen, doesn't matter it's complete or not complete, is you need to have that reaction itself need to have a resident time. Okay? Ataupun kalau you belajar reaction dipanggil tau. Okay? Do you have a resident time inside the stream in pipe? Can you hold that pipe there? Okay. Kat mana kita ada resident time? Okay, kita ambil case ni lah. Kat mana resident time to happen? Where?
Dalam flash.
Okay. Dalam case ini, resident time yang pertama sekali berlaku kat flash. Sebab flash tu you have a holding. There is a volume. Okay. Let's say lah dalam flash ni dia punya holding is equivalent to one hour holding. Maksudnya dalam masa sejam flash ni akan penuh. That's we call it resident time. That's we call it holding time also sama. Konsep dia sama, tahu juga. So dalam masa sejam flash ni kalau you tak discharge dia akan penuh. Okay. Let's say reaction SO2 dengan water ni resident time yang dia perlukan cuma 2 minit sahaja. To them to completely react to each other. Tapi you punya flash ni 1 jam. So bayangkan kalau dua ni berada dalam tu berapa lama, berapa banyak sulfuric acid akan terbentuk. Okay? Dalam flash itself. Sebab tu you need to remove one of them as far as possible, as fast as possible. Kalau you keep remain benda ni dua ni, and you transport it masuk dalam distillation column, lagi lah akan berlaku reaction. Okay, in order to avoid of course, yang akan sengsara dalam ni, yang akan cepat rosak dalam ni flash lah. Sebab ada dua benda tu masih ada dekat situ. Of course, you cannot say that there is any reaction tak berlaku langsung at all. Of course akan ada reaction pun, walaupun it's not completely happen, tapi masih akan ada reaction berlaku. Especially if the water already become a vapor, in a certain condition that it can be a vapor, then you have a H2O also in the vapor. So vapor in the vapor two phase, okay, sulfuric acid happen in the vapor phase, reaction happen in the vapor phase, then reaction will happen. Sebab tu, if you want to avoid it, make sure that water should be in the liquid phase, not in the vapor phase. Otherwise, it will react with the SO2, then sulfuric acid will form. So therefore, it is important here that you need to maintain water as a liquid dalam ni. Dan jangan ada pun water naik ke atas. Kalau ada, then you will have a H2SO4. You can ada sulfuric acid itu. Bila you bawa sulfuric acid ni, then apa akan berlaku? Yes, then your piping integrity will drop. Okay, basically stream in dengan stream out untuk flash tu, integrity dia akan drop sebab dia akan berkarat, mudah berkarat. Because sulfuric acid is very corrosive. It's a corrosive acid. Okay, sebab tu kita tak boleh ada benda-benda yang macam ni dalam plant kita. Okay. Dia akan makan sikit-sikit pipe tu. So those you're going to be reliability and also integrity engineer, that is basically your job. Okay, that is basically your task. Always checking the integrity, the reliability of your piping of your equipment. Okay? So that's why is it important for you in the first place to remove one of them, such that there is no reaction happen, therefore you don't have any acid gas inside your process. So first thing first, what you do is you need to remove the sulfuric acid. Okay, sulfur dioxide. You may have this, right? Okay, levels is you have ethane in the water here, then you maintain the liquid level. Okay, good. All right, the question is here. Team 7 or any yang lain boleh bagi pandangan tak? Why that in this case you need to pressure control the top of your flash. Tong, why that you need to pressure control this vapor stream? Oi, si Tong tidur ke?
Ada. Tak, bukan.
Ingat you letak you punya attendance, lepas tu you pergi makan ke apa ke?
Tak. Sebab ada satu kelas
Ya, why?
lagi nanti.
Oh, iya kah? Pukul berapa? Pukul 6?
Saya saja.
Why you are different? Alien.
Fail subject.
Okay, I thought you are alien.
Tak.
Okay, why that, Tong? Why that you design this?
Tak, sebab itu gas kita related dengan pressure dulu.
Okay, I know. But do you know that you are dealing with the SO2 here? Why you need to hold that SO2 there? This is an example of either you want to satisfy your control objective or you want to satisfy process safety objectives. Okay, kena balance kena balance. Of course, there is a vapor. Yeah, I know that you are controlling the pressure because there is a vapor there. Tapi kalau orang safety, kalau tengok ada SO2 situ, kalau boleh release cepat-cepat. Jangan hold. Jangan tahan-tahan dia. So no need for you to have a control valve over there. Just release. Lagi cepat dia keluar, lagi cepat dia belah, lagi senang kerja. Sebab sulfuric acid takkan terjadi. Takkan form. Okay, Tom? From the process control point of view, this is right. Nothing wrong with what you have designed. But from from the process safety point of view, this will basically encourage.
It depends on the content also lah.
Yeah, in this case, you tak boleh hold SO2 tu lama-lama.
Okay.
Because you are having water there. Kalau tak ada water, it's okay. You nak hold your design ni tak ada masalah, right? Sebab there's nothing that can transform the SO2 into something corrosive, something dangerous. But now you ada dua benda yang memang, yalah macam tadi lah, Nuha dengan Qayyum kan. Contoh. So kalau kena ada kansul, kalau kansul tak ada, dorang dua ni akan bergabung. Amin lah, doakan lah. Okay, so kena pisahkan secepat mungkin. Allah, kesian pula nak pisahkan orang dua ni. Okay, Tom?
Boleh, Doktor.
But in this case, yes, nothing wrong. From the process control point of view, yes, nothing wrong. But from the safety, you need to also consider benda ni. Okay, you cannot hold most dangerous component lama-lama. Alright, okay, so this, right, now you have a reboil absorber here. Why? Because you want to make water as a vapor. That's why you need to reboil. That's the easiest way for you to separate water with the ethane. Make sure the ethane still in the liquid phase. Wow, ini suhu masih lagi negatif lagi. How you reboil something with the negative boiling point? Oh, tak apa logik, but it's okay. Benda tak logik kan? So what is this? Flow control? Why you need to flow control the vapor stream?
Sebab kita ada take into consideration juga kan ethane has a lower boiling point dekat compare dengan H2O kan. So ini kita blur sikit mana satu blur sikit mana satu akan jadi liquid phase ataupun gas phase.
Okay. I think I'm wrong here. Should be propane ataupun pentane here. No, it should be propane or pentane. Okay. Tidak masalah. But this should be heavier. Should be heavier the carbon. Okay. Let's say that this is not ethane, it's propane. Okay. Propane. And make it pentane. Okay. So this is making pentane. So because I want to recover the carbon at the bottom. Okay. And water at the top. Alright. Then the boiling point will be positive here. Right, but water still higher, but it's okay. This is, but it's okay. Okay, assume that this is a higher boiling point than water. Okay. Ini saya minta maaf sebab ini ada kesilapan sikit because of the arrangement. Should be the bawah ni lagi tinggi boiling point dia daripada air. Otherwise, how you want to boil water there? Okay, So assume that this is, I don't know, the Pentagon still have a more boiling point than water or not? Hopefully it's not, huh? Or boleh that, huh? Pentagon berapa boiling point dia at the atmospheric condition?
36.1.
Alamak, lagi rendah.
Yeah, 36.1.
Okay, lagi rendah. Okey lah. Nasib baik korang ada satu group saja. Okay. We make a correction here. So you have a SO2, we have we have ethane, and we have water at the bottom. Okay. Then you will recover. Okay, this is right. So we'll recover ethane at the top, and you recover water at the bottom. Okay, again, this is, nampak you still have this and then this. Alright, in this case, you cannot flow control this because this is in vapor. Therefore, you need to control the pressure at the top. Okay.
Okay.
Ini pun sama juga, tak boleh. You need to, since you have a liquid here, then you need to maintain the bottom level. Okay, temperature. Alright, this is temperature to maintain the boiling point of this, to vaporize the ethane. Okay. Team pula group 7, okay? Question. Oh, almost jam lebih juga. Ada? Nuha? Kau dah buka kau punya mic tu?
Tak ada.
Okey, tak ada soalan. Okay, kalau tak ada soalan, then what I would like all of you to do now is do the correction. You can access to this. I will give you the link of this. Okay, you can copy whatever and you do the correction. And then after that, while doing that correction, I would like also all of you to do the second part of this exercise, which is do the variable classification for all the control loops that you have designed. Okay, the one that have been corrected just now, okay, based on our discussion. Okay, boleh? Okay, alright, so kita take rest dalam take 5. 3:25, make sure everybody masuk dalam breakout room. Jangan masuk sekarang sebab saya tak buka lagi. Okay, so saya punya USB dah penuh. Saya kena buka monitor dulu satu supaya senang saya nak tengok you all punya ni. Okay, take a rest until take 5. So 3:25 kita you all masuk dalam you all punya breakout room. Okay, while I'm setting this one, and also I will give you the link of this Jamboard. Okay, take 5.